Today we'll be looking at methods using Swift. As you can see up here, we've started off by giving that beginning change of our playground setting in Swift. Method in Swift has a couple of differences from Java. We're going to take a look at that really fast. We're going to do a sample one right here. We want to look at what it takes to actually make a method happen. And so just make a quick little simple method. We'll talk about the structure components, and we'll go from there. So the Java version, public or private, void does nothing. So here we have our Java version of a method. So public void does nothing. We have the keyword public indicating it's a visible method outside of this stack of code right here. The method type is a void, and it does nothing. Nothing actually happens in the method. It has no parameters as well. So the equivalent method here in Swift would look like this. So we would have func as a keyword. It would be does nothing. Notice our same case notation. And then I would simply have squiggle, squiggle. And of course my parens at the end. Sorry, can't forget those. So our func does nothing is fairly similar for a very basic method. It simply has the keyword func indicating it's a method. But to indicate it as a void type, it's different. Instead of having a keyword indicating a return type right here, like we do in Java, to indicate our keyword, if it's a return of void, we actually have nothing after the closing parens. We'll see this in a better example here with a return type. Say, for example, a Boolean method. So a Java version again, and so it'd be public Boolean is simple method. So we have our basic isTired method, and it would return inside it, return false. So that method right there in Java has an indication that it's a visibility of public. It's a Boolean method, and the method name is called isTired, and it has a single line statement returning false because they're never tired. To that in Swift, we would have a func, and we'd say isTired, has no parameters again. Then we use our return type indicator, aka the arrow symbol, or in this case it's going to be the minus sign and a greater than symbol, and then a space after that, and we type in bool, indicates a Boolean type, and then our squiggles, and return, and we'll say false again. So the functional structure of that method is the same. So you can see the clear difference here between a void method and a type method in Swift. A void method has no arrow indicator because there is no return. It simply just is there. It does whatever isn't there and it exits that block of code. However, if we have a return type method, aka a Boolean, a car, an int, a George, a string, anything that is returned from there, we indicate that return by the arrow symbol, aka the minus sign and greater than symbol, and then its return type. Now, void is a keyword in Swift. And so if we go back up here to our func does nothing method, which again has no code in it whatsoever, and we use the indicator to indicate it's returning something, and we use the keyword void, it still compiles. It is still returning nothing. If we want to see what would happen for the isTired, I could do print parens isTired. Not turd. I can type. And in my print isTired, as you can see right here, I am printing simply just false. It prints false out. But with the return type of void, the convention is to simply leave it blank like that. Does nothing. Has no return type because it is a void method. And so we do not indicate this right here. We don't have any indicator of the return type like we do for a return type method. So it's a little bit different than we see in Java. Java has an actual return type specified between its visibility and the method name. In Swift, our return type is specified not between the method name and the visibility, but rather the return type is specified after the method name is defined and its parameter list right there. And all methods begin with the keyword func. So we will get funky with Swift every single time we use methods. Questions? The question is how to get it so to print false. So up here, you do have it so it shows the using methods in Swift right here, right? Okay, make sure you don't have anything that would cause a compilation error or a syntax error or a runtime error inside your code. In this case, I've got simply a definition of a method and I have my parens, and I have my print boring, which doesn't do anything, but that's okay. It would print it when it gets called, and that is all. And then I have my isTired, func is tired, parens of returns of type bool. I'm saying it will return false. I make sure I have my squiggles lining up right there. Missing a parens. Okay, so again, that's a great thing to notice. If you're missing parens, like say for example right there, I get my lovely errors, and you can see that this grays out because it's not actually happening. And so if you do not see something happen inside your playground, generally the problem is that you have a compilation or runtime error that's preventing the execution sequence from happening over here. So just as an FYI, great time to save, great time to commit. Those methods are really, really simple. They don't do very much, and we see the comparison between how it would work in Java versus the same thing working in Swift. So the language style is a bit different. So we're going to go down and give a bit more space for this. We'll play this more. We'll make a bigger method, one where we can see a little bit more of actually what's going to happen. Now, a couple things to note that when we're dealing with playgrounds, since this is not this is a live code experiment type thing, if we want to call a method, we have to have it defined up here before we can call it down here. So I can't say, for example, call, if I say a method, say func does something, parens, return string. So as you can see right here, I have a method called does something that returns string. I can't call print does something right here because does something has not been defined yet. Oh, I guess it'll work, but we get a warning. Use of unresolved identifier does something. So it works sort of, but it doesn't. This should not happen. So if we're using the playground feature, we get this lovely error message because we haven't defined does something yet. So that's why it's giving an error, even though it's actually showing what happens. It's not actually working because it hasn't been defined yet. So you need to make sure when we're dealing with this, we don't call a method until after we've defined it. So now I can go right here and I can simply just call print does something, and it works just fine. That's an important thing to notice, is that we must actually define our methods first before we can actually call them in Swift. So if we're actually in a Swift file, that's not the case. It works just like Java. I can have all my methods in any spot in the code. But in the playground, aka right here, when we're just testing out stuff, we have to define it first before we can use it. Save that. We'll move past that. Let's go take a look at a bigger, more complex method. So let's make a more complex, powerful method. And so it's going to be a func as our keyword for method. And we're going to check variable, or check value. And it will be passed a some number. And that's of type int. And so this is a some number of type int. And we'll have it, it's going to return, we'll have it return a string actually. So right now we're going to we have some number of type int, it returns a string. As you can see right here, we have an error indicator on our bottom line. I have to return something exactly. So because I declared this of type string for return type, I must return a string before I'm done. So we're going to do some if logic on this so we can practice with an if as well, because we want to use our control structures. And so we're going to have some value happen based on this. So again, just like we do in Java, we're going to declare a string type. So we're going to have our good structural code. And so we'll say that we have var, and this is answer equals, or answer is of type string. And we'll say that it equals blank, because we initialize it to a value. And our last line of code would be return answer. So immediately we're following that same standard policy that we've been using in Java, where we define a variable at the beginning, initialize it to an acceptable value, and return it as our last line of code. This means our code is functionally compilable, it's also correct, and it's going to do something. It's going to work properly. So we have that ready to go. And now we're going to go ahead and we're going to get this ready so we can actually have some tests happen. We're using some logic inside this project. So to do that, we're going to go here and we'll do an if test. And we'll if, and we'll say that some number less than, let's say, -5. Then we will say that that number is small. Do an else if, just like Java. Else if, and then some number equals 0. And answer equals, we want a smiley face. You can also just pull that up by doing Control Command Space. I was doing Option Command Space, that's why it screwed up the window a minute ago. But Control Command Space allows you to get to the smileys and Unicode features. And then we'll do a final else. And answer equals. We have now a sequence right here where we are going to take in some number. It returns a string based on that number. So we have if it's less than -5, if it's equal to 0, otherwise if it's greater than 0, we have a value for that. So let's look at what it takes to actually call that method. Now, we've already talked about the structure differences between Java and using the method. But let's look at the difference in calling a method in Swift versus Java. So if we're going to call some method called checkValue that takes a number as a parameter, it would just be simply like this, Java version. We would say, we'd call the method checkValue, and we'd pass it just like, say, 4 and a semicolon, right? To do the same thing, however, in Swift, it's a little bit different. Swift wants us to actually clarify as when we're calling a method what we're doing with the parameters we give it. So this is where it's really important to name things appropriately. Because in Swift, it's going to look like this. We're going to say print parens, just we want to print this out. We'll call our method checkValue. And we're going to say that some number, colon, and then the value. Okay, I'll have to check that out. When I was playing it with the init, I actually had to call the parameters. So we'll check that out here in a second. Maybe it's just with single parameters, but the same structure approaches with Swift then. Okay, I'll have to check this out in a second. Let's try this. So it's only when it is a second parameter it's required. Okay, I was wrong. That's okay. This is where Swift is a little bit different though. So as you can see right here, if I was going to do this in Java, it'd just be calling it like this. I just do pass it some string, some stuff like that. In the Swift version though, if I have multiple parameters, I have to specify what that parameter is being assigned into. In this case, I have right here words is going in, as does is going into words, and I have 453 for that some number parameter. Okay, so the first parameter, it can get away with it. The second parameter, it needs to have that parameter header attached to it. You must specify what this is when you pass it. But so we have right here, we have that method where we're checking this. We declare it of type string, that's the return type. We use that arrow indicator to identify its return type. And we did their usual structure that we did in Java, where we define a value and return that value to have our clean code so we know that our code always compiles and always works the way it's supposed to. And so we don't actually need that words colon string in there, so let's go ahead and take that out. And take out the words colon address right here because we don't need that in there either. And clean that bit of code up for the final, because that's just for showing notes. So the Java version and the call version in Swift are basically the same with single parameter methods. If it's a multi-parameter method, we have to actually give it more information than we do in Java. So let's do that as a formal part right here. So we'll say a func and multi-parameter method. And it will say, and this is, we'll have this return a string, just because it's nice and convenient to return strings. And so we'll say we have a var and combine is of type string equals blank, return combined string. In Java, we have our combined version we could just do string head the concatenation operator, aka the plus sign, or I could do words plus quotes plus age plus quotes plus values, and I could combine anything into a string just like that. However, when we're doing this with Swift, we have a little bit different way of addressing this. When we want to deal with this in Swift, we say our string variable equals words plus, and then we're going to interpolate is the term they use for it. And so we're adding it's inside a string, so we have our quotes that we're going to deal with. But inside the quotes, we're going to have an escape sequence where we have the backslash and then the parens to indicate that we're going to put those values inside there. So we're going to put the age, and I want to put and then the backslash quotes the values. And so that'll add those values in there as one single string. And if those spaces are already indicated, as you can see right here, we have a space in between age and values, and a space after that. And return that string. So let's take a look at how to call that as well. So we're going to go ahead and print a multi-parameter method. And we're going to say that we are passing it some quotes for our string. So Cody, comma, and then our age, colon, and we'll say 2, 3, 4, 5, and then a comma, and then values, colon, and it's a double value, and so we'll say 987.765. And so I'm printing that multi-parameter method. As you can see, it's going to grab that Cody, the 2, 3, 4, 5, and the 987.75. It goes up into the method, because we've defined it already, passing words that string value of Cody. The age gets past 2, 3, 4, 5, and values gets past the other number. It takes the string, starts it off at 0, and then says combined string equals words plus age values. So I have Cody, 2, 3, 4, 5, 987.75. We can try that again with another sequence. So print, and then we're going to call multi-parameter method. And again, we have to, our first parameter, we don't give anything to it. We simply say words for class. Then a comma, our second parameter, gets specified as to which one it is. In this case, age. And our class we'll say is what, 7 months old, 6 months old. And then our second one is our values. And we'll say 30.1 for the approximate number of students we have. And so that first time it is printed, it gets Cody 2, 3, 4, 5, 9, 8, 7, 7, 5. The second time it's words for class 30.1. This is a great screenshot moment indicating that we have right here, we have our method of doing this. In Java, it would look like this. Let's do the Java version as well. So give a little notes, Java version. So in Java, it would simply just be the call, method, and then stuff. And so if you notice right here, we have this 2 times listed right here. That means this method has been called twice. I have changed this. If I have another line right here, if I call that method, it would change to 3 times. So if I were to say right here, I go down and I copy this again, copy, and paste. It now goes to 3 times. That's how many times this method has been seen inside my code. That's one of the nice features of the playground of Swift, is we can see how many times our code is being executed just as we actually type our code and watch it. So this is a great tool for looking at code. Quick review of what we just did. We have the Java version. Java would have the keyword void. Boys. Okay, so again, reviewing this for us, comparing Java to Swift in methods. In Java, we have the keyword void, happens between the visibility and the method name. The equivalent function in Swift, there is no keyword void that we use. It simply just does nothing. And then I do not use the indicator of return type, in this case the arrow sign. So we have our does nothing function. It's simply just a void method. I can calculate values in a method normally. We have our boolean method where we simply return a value. Again, we look at that. Our public boolean is tired. It'd be func is tired, returns type bool. And so the way I'm going to suggest saying this is the function is tired, and then whatever parameter list we have, returns type is how I will say this. So the arrow indicator is returns type. So function is tired, returns a type of boolean. Function does something, returns type string. Function check value takes some number as a parameter of type int and returns a string. Function multi-parameter methods takes a words, age, and values as parameters and returns a string. So we have that. We played that. We tried that out. We saw that we can use an if and else if. If and else work pretty much the same. Now, one of the things I do want to indicate on control structures, if it's a simple test, you can do this. I can just say if some number is less than 5. And I go back here and I pass it 3. Or negative 3, excuse me. Helps if I actually put the right one. Oh, negative 3 is not less than 5. Negative 9. There we go. That number is small. Helps I actually read my own test. Fantastic. So negative 8 is less than 5, so it prints out that number is small. We don't have to have a parens on the if test in Swift. I require them. So you'll see stuff in various like online tutorials, etc. Don't follow that. Give it parens, especially on compound statements. Compound statements, it's really important to actually give some structure to it, watching what you're doing. So I'm just going to say I'm requiring the parens to be on there just because I want your code to look good and understandable when you're working on it. So ifs and else's work the exact same in Java and Swift. We'll be using them the same way, just keep that in mind. The tests work the same, numbers and math work the same in Java and Swift. It's just like regular math. We have it ready to go. Okay, so we've got that. We've taken a look at some of the methods we can use with Swift, how to build those methods. We have the idea of a void method, a Boolean method, and of string methods. When we have a single parameter, we do not have to actually pass it a label for the parameter. And if we have a multiple parameter method, in this case we have 3 parameters right here, the first parameter does not need a label, but each subsequent parameter needs the label attached to it. So that's the difference between Java and Swift. Java, we never had labels on our parameters. In Swift, we must have labels on our parameters. And so it's very important that if I change my label, my here, I could leave that as simply just A and V. And that would cause problems because what would I know to put in this case of AV? If I leave it as something like that, I won't know what I'm actually putting in. So this is why it's very important to give good variable naming convention inside your code. Because I have no idea what A is standing for. An age of 2,335 doesn't make sense. But A of 2345, oh sure, why not? So it's very important that we actually give a good naming convention, especially on our labels, aka our method header or our init header. It's very important we give a name for those things that make sense, because otherwise we are not going to know what is going to go inside here. So I'm going to undo all that garbage because I don't want that to stay on my code. And so we want to make sure that our label of our header makes sense. We have good variable names. Variable names are our friends.